Hey, my name is Tyler Westcott. I'm in the ITL 518 Science and Integrative Design. This is my video about doing a science experiment. We're going to be looking at the next generation science standard, matter and its interactions. In particular, the disciplinary core idea is about chemical reactions. Heating or cooling a substance may cause changes that can be observed. Sometimes these changes are reversible and sometimes they are not. We are going to be looking at phase changes of water and how this is a chemical reaction adding heat to matter. In this case, water is going to create an observable change. We will talk about how that's reversible. We will be heating it up, but for this experiment, we won't be cooling it back down and showing the reverse phase changes. And we're not really diving into the sometimes these phase changes or changes are reversible and some are not. For this case in point, we're just going to say that they are reversible. So the learning goals are going to be to have my students understand that adding heat to matter is a chemical reaction and is causing an observable change. I would like them to understand some key vocabulary terms in terms of solid, liquid, gas, melting and freezing, evaporation and condensation. Just talking about those phase changes. So that would be another learning goal. And we're also going to be looking at visualizing this and trying to see that there are specific moments, specific amounts of heat or energy that create these phase changes, and it's not just random. There's a specific heat which cause these changes. I may just mention that it changes with different types of matter, but for this we're going to just focus in on water and look at those specific times for that. All right, so I'll be doing starting with the experiment, not really diving into any of the lesson or direct instruction of he's learned in this class. We should start with the experiment and go into the content later. So in my classroom, I would have a hot plate with a pot and show that we have some ice cubes, and then we turn it on. Can have them observe that these ice cubes are already melting a little bit. Ask them if anybody knows that term, melting, and then we would get the heat going. All right, as we get down to our ice cubes are liquefied here, I would ask any of my students, what do you think is going to happen next if we keep heating it up? Some may say boiling. If I say that, I would ask them if anybody knew what's the term for when we go from when we start boiling and we see steam come up. Does anybody know what's happening there? There's a term for it. It starts with E. If anybody knew, I could give them praise for that. If not, I introduce the term evaporation, and then give it some time for us to start boiling. And as we start boiling, I would point out to them to notice the stuff coming off of that. Ask them if they know the term for that. Some may say steam. They'd say yes, that's steam. It also could be called water vapor, which is also a gas. Gas is what we're looking for. We went from a solid, which was the ice cube, then we went to the liquid, which was the water, and now we're moving to a gas, which is all this steam that's coming off. That would be the experiment for now, and then we move on to a lesson that I would do on the carpet, which I'll show right now. So here's a kind of a rough written out visual that I would create for this lesson. Here we have a sort of linear chart with temperature on the bottom showing our temperature where we have our 3 phase changes. And as I mentioned, I'd kind of introduced these terms solid, liquid, and gas. So I explained that when we have our ice cube, we would it would not turn into the water to liquid until it hit 0 degrees Celsius. And then I could also just say that's 32 degrees Fahrenheit. And then it gets heating up, it's heating up, it's heating up, it's getting hotter, that water is getting hotter. Then at 100 degrees Celsius, we would be turning into that steam, water vapor, which was a gas. And then from there, I can introduce these terms too. Melting, once we go from a solid to a liquid, we're melting. From a liquid to a gas, we're evaporating, or evaporation. And from there, I can get into some more higher order thinking questions. For example, I would ask, can somebody take a guess, an estimation of what temperature is inside the freezer where we find the ice cubes? Hoping that they would see this chart and know that it would have to be somewhere less than 0. Vice versa, I could ask, well, we had our heat source that was heating up our liquid and it made it boil and evaporate, turn into a gas. So do you think that heat source was less than 100 degrees or higher than 100 degrees? And ideally, hopefully they would say higher than 100 degrees because they would need that much heat to turn it into a gas. So basically at the end of this, I would make this look a little nicer, some more color, some more pictures, but I would have them copy all this in their science notebook with these definitions as well. Yeah, that's the bulk of the lesson right there. As far as the informal assessment, it would just be checking for understanding throughout, asking a lot of questions. There's definitely be some lull periods as the ice cubes are melting and boiling. So it gives opportunities to ask if they're aware of any of these terms, asking them, what is it called when the ice cube goes to the water? Seeing if they already kind of know these terms and then connecting them to the actual terms that I'm looking for them to use, like solid, liquid, gas, talking about matter as its physical substance that has like weight or mass. So just asking a lot of questions, asking the group for yes or no, as well as individuals to answer specific questions. All right, thank you.